Hi guys, welcome to today's lesson. So today we are going to be talking about the reproductive cycle and hormones that go along with that cycle and how these hormones work. So this lesson is going to be relatively intense because there's a lot of words and there's a lot of kind of complex interactions. So this is one that you might have to watch through a couple of times to really get it. This is why I've kind of put it in its own lesson as opposed to putting it along with other parts of female reproduction. So first we need to talk about what the goal is here. And the goal of the reproductive cycle is to get a female to a point where she could conceive and carry a pregnancy. So this is true with the majority of mammals, mammalian species, including humans. And for our animal species, there is a window of time where that female could breed with the male and where that sperm could actually make it to a fertilized egg. So everything has to line up in order for a pregnancy to take place. And this window of time when the female is receptive to the male is known as estrus, this top word here. This is estrus with a R-U-S, all right? This is also known as heat. So if you've ever heard of an animal coming into heat, that's what we're talking about here. We're talking about estrus, all right? So you'll notice that there are two terms called estrus. One is spelled with an O-U-S and one is just U-S. So this top one that is just U-S is this period of sexual receptivity. So this is when a female will stand and allow a male to breed her, all right? So that is heat. The other form of the word is O-U-S, estrus, sounds the same, spelled different, and this is the description of the entire reproductive cycle, also known as the estrus cycle, okay? So when you're talking about the entirety of the cycle, so estrus synchronization or the estrus cycle, we're talking about the O-U-S adjective version of the word. And if we're talking about the period of heat, the period of sexual receptivity, we're talking about the U.S. noun version of the word, all right? So I have some examples down here. If you're talking about a cow being in estrus or being in heat, you're talking about the noun version of the word. And if you're talking about the average length of the estrus cycle, the entirety of the cycle, you're talking about the OUS version. Now, I'm harping on this because I don't normally take off for spelling, but if you get these two mixed up, you will get them wrong on an exam or on a quiz. So these are ones that you really do need to pay attention to. All right, so estrus, just US, is the noun version. OUS is the adjective version. All right, so when we're talking about livestock species, that period of receptivity isn't all the time. It only happens at certain points during the estrus cycle. And the length and times of this window is going to vary a lot depending on the species we're talking about, all right? So humans are a little bit different in that there is a larger window of time in which a woman can conceive, but for animals, this is a pretty narrow window, and it's usually like within a couple of days that you have a window there. So that is what this table shows. This table shows the species and it talks about the length of the estrus cycle, so the entirety of the cycle, all right? And what you're noticing here probably is that they're basically all the same with the exception of sheep. So the ewes estrus cycle is significantly, well, not significantly, a few days shorter. And that being said, her duration of estrus is got a little bit tighter of a window here, all right? So cattle, pigs, goats and horses are all the same at an average of 21 days. Now, these are averages, so that means that the cycle could go a little bit longer and it could go a little bit shorter, and that's going to vary from cycle to cycle and from animal to animal as well. So some of them just have traditionally, you know, their cycle is just a couple days shorter, and that's just how they are. And then some of them have a little bit longer. Very similar to humans, in that sometimes their cycles are varying length, and that could vary from cycle to cycle as well. There are things that can influence this. Nutrition, stress, environmental conditions can all influence the length of estrus a little bit, or the estrus cycle. And as far as duration of estrus, this is that window I was talking about. This is that window of receptivity. So this means that the female will stand and allow herself to be bred by the male. So for a cow, it's 24 to 48 hours. For a sow, it's 48 to 60 hours. So we have a bigger window with pigs. For the ewe, it's anywhere between 36 and 48 hours. So a narrower window, but a longer length of time. The doe is the same as cattle, 24 to 48 hours. And then the mare is our longest at 2 to 8 days. So the mare and the ewe actually have seasons to their estrus cycles. And we'll talk about that a little bit more later. But these species don't cycle year round like cattle and pigs do. So sheep, goats, horses, they are all seasonal with regards to their cycles. Okay, so when we're talking about the seasonality of these cycles, when we have animals that rely on the length of the day in order to trigger their cycles, we call that seasonally polyestrous. All right, so that means they're seasonally dependent, and poly meaning many, estrus meaning estrus cycles. All right, so this means that during their season they have multiple cycles, but only during that season. So for sheep and goats, they begin to cycle when the daylight hours begin to lengthen. So in the fall, when the days, when the daylight hours start to shorten and the nighttime hours start to lengthen, that's when we have sheep and goats coming into their cycles. So in the fall, so typically it's after the summer equinox. So once the days start to shorten a little bit after the longest day of the year, usually you start to see them come in late August, early September. And then in horses, it's the opposite. So when the daylight hours start to lengthen, that's when we start to see the horses come in. So usually like December, January is when you'll start seeing horses come into their cycle. And this is controlled by the daylight hours. So the amount of light they are exposed to communicates with the pineal gland in the brain, and this secretes melatonin or not. It either turns it on or shuts it off. And this is going to influence how the reproductive organs respond to the hormones that are being produced. All right, so the hormones are being produced year round, but the body's responsiveness to those hormones changes depending on the length of day. So some of you probably have taken melatonin as a tablet at some point, and maybe to help you sleep a little bit. And it makes you sleepy, but it also helps regulate body functions. And so for animals, we use melatonin to help stimulate cyclicity. So yeah, fun fact. It is not widely used in the US. It is used mostly overseas, but it can help to stimulate them to start cycling a little bit early. You can also adjust the amount of light that they're exposed to. So if you have a closed barn or something like that where you can completely control the amount of light they're exposed to, you can lengthen the cyclicity period. So you can lengthen their season or shorten it if you wanted to. This works best with horses. It doesn't work as well with sheep and goats, and that's mostly because sheep and goats are in barns that are lit with natural lighting a lot more, and you can see horse facilities are a lot more enclosed typically. Okay, so we're going to talk now about hormones, and hormones are major drivers in the estrous cycle. So everything that happens with regards to fertility is controlled by hormones. And we have a list here. There are 6 that we're going to talk about, and they are easy to get mixed up. Some of them sound similar, so you really need to pay attention here. These little abbreviations in parentheses, you can use these on your exams. So unless I specifically say no abbreviations, you can use these abbreviations. They're easier to remember, but make sure that you know which hormone they go with. All right, so we're going to talk about these individually one at a time, starting with GnRH. So GnRH stands for gonadotropin releasing hormones, and it is produced in the hypothalamus of the brain. It's probably one of the bigger hormones in that it kind of controls a cascade of other hormones, and it is produced by this little tiny gland right here called the hypothalamus, and it kind of controls this like downward cascade of release of other hormones. So when gonadotropin releasing hormone is released, it actually acts on the pituitary gland, which is that little tiny gland that's right underneath the hypothalamus. All right, and it basically tells the pituitary, you need to release these hormones, and these hormones are FSH, which is follicle stimulating hormone, and LH, which is luteinizing hormone. So follicle stimulating hormone is produced by the anterior pituitary. So if you look at the pituitary gland, you'll notice it's broken into 2 distinct sections, and the anterior pituitary and the posterior pituitary. And most of our reproductive hormones are going to come from the anterior pituitary. So the front part, so if you are looking at the front of the animal, like the animal is looking directly at you, the anterior pituitary is closest to you, and then the posterior pituitary is behind that. All right, so follicle stimulating hormone does exactly what it sounds like. It stimulates follicle development. So FSH actually communicates with the ovary. It communicates with the follicles specifically on the ovary, and it causes them to start growing. And remember how I talked about in a previous video that the follicles on the ovary start off really, really small, and then they get bigger and bigger and bigger, and eventually they pop, and that popping releases the egg. Well, follicle stimulating hormone is one of the hormones that kind of helps those follicles to start growing. And it also stimulates the production of estrogen, which is a really big reproductive hormone that we're going to talk about in a little bit. But estrogen does a lot for the reproductive cycle. And so follicle stimulating hormone communicates with the ovary and kickstarts that follicle development, and those follicles then are stimulated to produce estrogen. Luteinizing hormone is also produced by the anterior pituitary gland as a response to GnRH, and luteinizing hormone is what's going to cause those follicles to pop. All right, so they need to pop in order to release that egg, and that is called ovulation. All right, ovulation. So that is the bursting of the follicle to release the egg, and luteinizing hormone is responsible for that. So luteinizing hormone does a lot of complicated things, but one of the things that it does is help weaken that wall of the follicle so that it can pop. Luteinizing hormone is also responsible for development of the corpus luteum. So remember, we talked about the corpus luteum, and the corpus luteum produces progesterone. It's a structure on the ovary that actually develops where the follicle was. So the follicle cells change into the corpus luteum cells, and luteinizing hormone is responsible for this transfiguration. All right. So luteinizing hormone, another super important one, because without the corpus luteum, we're not getting progesterone, and without progesterone, pregnancy isn't happening. All right. So LH is responsible for ovulation, and it's responsible for the development of the corpus luteum. All right, estrogen. So estrogen is produced by the follicles on the ovary, and FSH is going to help kind of stimulate the production of estrogen, because as those follicles get bigger and bigger, they're producing more and more estrogen. So we want those follicles to grow because estrogen is super important. One of the things that estrogen is responsible for is sexual excitability. So when those females are in heat, that heat behavior is a result of increased estrogen levels. All right. So as those follicles get bigger, they produce more estrogen. And when there's a great big follicle on there, that female will come into heat, because when that follicle is really big and ready to pop, that's going to release the egg. And so she's going to need to get bred in order to conceive. So it all kind of works together in almost like a cycle. What? Yeah, so that's how it's going. All right. So estrogen is also going to increase fluid production in the reproductive tract, and it's going to increase muscular contractions in the uterus. So those contractions are going to help draw the sperm up into the uterus and into the oviduct, where they are supposed to go to meet the egg. When estrogen gets really, really high, so when that follicle is at, peak size, it's going to talk to the brain, and it's going to say, hey, we have a really big follicle here, and that follicle needs to be ovulated. And the brain's going to be like, I got you. And it's going to trigger the release of LH, because remember, LH is responsible for ovulation. And so LH needs to happen in order for that ovulation to take place. So estrogen is communicating back to the brain and saying, hey, we have a big follicle here, you need to take care of this. And the brain is like, all right, we're going to take care of this. All right. So that's kind of how that feedback occurs. All right. So P4 stands for progesterone. Progesterone. All right. So progesterone is produced by the corpus luteum, which develops in place of that ruptured follicle. So all those ruptured follicle cells are going to change into luteal cells. And that progesterone that's being produced is going to help support the pregnancy. All right, so progesterone needs to be at adequate levels in order for the pregnancy to be maintained. Without it, placentation doesn't take place properly, nutrient exchange doesn't take place, and the pregnancy won't be viable. So she will have a miscarriage. So it's really, really important that progesterone is at high enough levels during pregnancy. So P4, progesterone, is our pregnancy hormone. All right, its main job is to maintain the pregnancy in the animal. All right, this long, convoluted looking abbreviation, it's PGF2 alpha, or prostaglandin. Now, it's easy to get prostaglandin and progesterone mixed up, so I'm telling you right now, don't do it. Make sure you know the difference. So, fun fact, prostaglandin is my favorite hormone, and I like to call it the assassin hormone, because what it does is it kills the corpus luteum. So in the event that the female does not get pregnant, she has this big old corpus luteum on her ovary that's making progesterone, trying to support a pregnancy that doesn't exist, right? Well, the purpose of the reproductive tract and the reproductive system is to get pregnant. So if, for whatever reason, she either isn't exposed to a male or doesn't get pregnant, the cycle needs a chance to restart, because it's not going to just be in the pseudo pregnancy stage for the rest of the animal's life. So somehow that corpus luteum has to be cut off. And that is the job for prostaglandin. Prostaglandin is actually produced in the innermost lining of the uterus, so the endometrium. Remember, we talked about how the endometrium is super glandular and secretes all sorts of fun stuff. Well, prostaglandin is one of those fun things that it secretes. In the event that the female doesn't get pregnant, The endometrium goes into this like, well, there's nothing here, so something's got to give. And there's a very complex series of steps that the uterus goes through in order to make that call. But eventually what it does is it starts to secrete this prostaglandin. And prostaglandin acts directly on the corpus luteum and it cuts off its blood supply. So it kills that structure. And it's very selective. It doesn't kill off the entire ovary. It just kills off the corpus luteum. And one of the ways that it does that is it cuts off the blood supply to the structure. So it really truly is an assassin hormone, and that's one of the reasons why it's my favorite. Okay, so now we're going to talk about the estrous cycle of the female, and we're going to use the doe, or female goat, as our example. So this could also count as cattle as well. It could look the same for cattle. I realize now that my numbers are a little bit messed up, but we're going to work through it anyway. You guys will be able to follow me, I'm pretty sure. All right, so first of all, let's talk about FSH. So we get these, so this is, day of the cycle here. And then you could say here would be like your relative level of hormone. So what you're seeing with FSH is a little loop, a little like raise in her cycle, right? Because we need to start stimulating follicle growth. That's what we need here, right? And that is going to trigger, as those follicles get bigger, that's going to trigger a release of luteinizing hormone, because that luteinizing hormone is going to cause that follicle, that big follicle, to ovulate, right? So when FSH is growing and gives us that little bloop in the radar here, it's going to cause follicles to grow, and the bigger the follicles get, the more estrogen they're producing, right? So when they get to a certain point, the estrogen is going to communicate with the brain to get that LH to surge, right? And say, hey, we need to ovulate that follicle. So LH is going to be like, yeah, all right, cool. So it's going to talk to the ovary, and that large follicle is going to burst, and then estrogen is going to go way down, because we don't need estrogen anymore, right? Because now we have an ovulated follicle. So that estrogen level is going to just bam, way, way down there. All right. And after that estrogen level goes down, we're going to start seeing an increase in progesterone, because as those follicle cells change into luteal cells, they're going to stop producing estrogen and they're going to start producing progesterone. And that's going to go up. And then progesterone is just going to kind of cruise along here at, kind of a peak level for a long time. All right. So the majority of the estrous cycle is going to be with these high levels of progesterone. But then what happens over here? Progesterone just suddenly goes down. What happened? Well, what happened is prostaglandin came in here. Prostaglandin comes in and kills off that corpus luteum, because that animal isn't pregnant and needs to restart her cycle. So prostaglandin will hit right here, and that will cause the level of progesterone to go down, and it will allow for a restart of the cycle, which is over here. Okay, so this is the estrous cycle in a nutshell, and kind of what the relative levels of hormones are doing. So you need to have a general idea of what this cycle looks like. All right, and we're going to probably do an exercise that's going to show what this is going to look like. All right, so when we're talking about the estrous cycle can actually be broken into two phases. All right, so we have the cycle as a whole, but we have what we call the luteal phase, which is when progesterone is really, really high and the corpus luteum is functioning. And then we have the follicular phase, which is when the follicles are growing and growing and growing, and up until when those follicles burst. All right, so those are our two main phases. And then we also have another way to classify those. And those additional phases are estrus, so the time when she is in heat. Then you have medestrus, and then you have diestrus, and then you have proestrus. And you guys are like, oh my gosh, these are a lot of words. Yes, I know there's a lot of words, but we have a chart. Okay, so when we're talking about the follicular phase of the cycle, we're talking about these two sections right here. All right, so the proestrus section is immediately prior to heat. All right, and we have these follicles and they're growing, and this little dotted line right here, this is estrogen, right? So estrogen is going up, 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 and then it peaks, and then the animal ovulates, and that drops way off. All right, so we have proestrus here, which is the time of follicle growth immediately prior to a heat. All right, and then when she goes into heat, that's the estrus phase of the cycle, right? And then after ovulation, that's the end of the follicular phase of the cycle. Okay, so proestrus and estrus are our follicular phases of the cycle. Okay, and then once that animal ovulates, her estrogen level is going to go down, progesterone is going to go up, and that period of exchange here where the progesterone level is rising, that's called medestrus. All right, medestrus. And then once that progesterone level gets pretty high and peaks, that is diestrus. And you'll notice diestrus is pretty much the majority of her cycle. All right, so that's when progesterone levels are really, really high. So medestrus and diestrus are, those two together make up the luteal phase of the cycle. Okay, medestrus and diestrus make up the luteal phase, and proestrus and estrus make up the follicular phase of the cycle. All right, big picture stuff. Make sense? Let me know if it doesn't. Okay, so I know that was a lot. There was a lot of hormones, there was a lot of functions, there was a lot of phases. So make sure that you go through and you really understand what these mean, because I'm going to be asking specific questions about the estrous cycle and about the hormones and what they do. All right, if you have any questions, please contact me and I will get back to you as soon as I can. I hope you guys are all doing well, and I will be talking to you soon. Bye.